Okay, good afternoon. Welcome to the presentation of Benjamin Stangl, Master Architecture, right?
Yeah.
And so the procedure, you know, you have been through it already, 20 minutes, about 20 presentation, and then questions, and afterwards we'll discuss it. Okay, floor is yours.
Okay, thank you very much for being here. I will do the presentation in English because most of the literature and the people I talked to were English speaking, so that's why the reason that working on the presentation will be in English. Today I will talk about how digital tools shape the way architects think. So what I was interested in to find out is the relationship between the design process and design tools, especially digital design tools. Now, besides a personal interest in that subject, I saw that there is some kind of lack of research in that area that I wanted to go into. The scope of the project is to give an overview of which and how these digital tools are used in architecture today, particularly focusing on the shift from manual tools to digital tools, as well as looking at the effects on the design process itself. Now, when we look at digital tools, there is of course a big difference between mainstream architecture and the way they use these tools and the avant-garde. However, I tried to cover both ends of that spectrum. The approach that I used was to analyze literature, conduct interviews, speak to experts in that field, and analyze example projects. Today we'll talk about 4 main points. The first point is, why are we actually using computer-aided design in architecture? Now, in 1985, James Love identified 3 reasons for introducing digital tools to architecture. The first one is efficiency. This mainly addresses the drafting process of architecture, the document production, and it basically meant that existing operations could be done faster due to digital tools. The second aspect addresses the generative use of digital tools, which increases the scope of activity. The architects can now do things that they couldn't do before with manual tools. This may be the case of more complex geometry when it comes to analyzing a large amount of data. And the third one is something that he called Ferschin. Now, I might talk about a culture and a design discourse that where devices, especially rounded contours, are omnipresent in our everyday life. And in order to handle this complex geometry that is not describable through arches and circles, the automobile industry, Thiessier and Castacheux, were the first ones who developed very efficient ways of mathematically representing these curves and using these curves in the design of their cars, also already with digital means. Now, there are, of course, some bases of why we can use these complex forms now. As one of the first devices that used graphical user interfaces was the sketchpad, which already introduced some very interesting manipulation techniques such as scaling, zooming in and zooming out, copying and rotating. And the way we use digital tools today are very, very similar to these ones. And of course, as I mentioned, new ways of efficiently representing complex geometry was another basis of the success of digital tools. Now, when we look at, there has been a lot of software developed in architecture and in other design fields. And at the top of this timeline, you see the release dates of architecture software starting in the 90s up to in the years of 2010. Now, there have been studies done saying that around 50% in Europe and even more in North America use building information modeling software, which is basically the software that's on the top of the timeline. However, architects also use a lot of software which was originally developed for other design disciplines. That's, for example, in the case of Frank Gehry, who used CATIA, that was mainly used in and developed for the aerospace industry. And he used this software, and also engineers with the know-how from the aerospace industry to handle the complex geometry that he tried to design with. We see this happening, for example, in the area of film and video game and animation, where software which was originally developed for other disciplines was taken by architects. As well as we see a know-how transfer and input from computer science, especially when we talk about this very popular Grasshopper tool that's being used today. Now, next I would like to talk about the stages of how these visual tools came into architecture. Now, in the pre-visual stage, the tools that the architect used were, of course, manual tools, and they shaped a certain universe of geometry that the architects could efficiently handle. Now, Mitchell said that architects tend to draw what they can build and build what they can draw. So this connection between the means of representation and the means of construction are, I think, particularly interesting, especially because both parts, the representation part as well as the construction part, dramatically increase with digital technology. Now, however, there are always exceptions, of course. But when we look at the first phase of introducing computer-aided design to architecture, it was mainly the imitation of existing tools. So that meant that the operations that were done manually could now be done digitally, and they could be done perhaps faster, more accurate, but mainly it was imitating existing technology, manual tools, and bringing it into computer-aided design. Now, however, I believe that these tools have much more to offer than just using it for imitating what could be done before. Now, and that requires to look at digital tools as a medium of expression. Now, probably the most direct way of architects to express their design ideas is through sketching. And I believe we have to expand this a little bit and look how digital tools can actually, similarly to sketching, be a generative part in the design process. And therefore I would like to give you a few examples. The first one is reverse engineering, where technology played an essential part in the design process itself. Now, it was Georg used technology to digitize physical models and create visual models with that, manipulate these visual models on the computer and create physical models again. And this procedure was done in an iterative loop. So this is an example where technology becomes an essential part of the design process itself. Now, the next one I would like to talk about is parametric design. Now, parametric design is very popular today, and I believe probably that every design can be claimed to be parametric in one way or another. However, there's something particularly interesting in parametric design that makes it very capable of transforming it into and using it with digital tools. Now, Antonio Gaudi, I would like to give an example here, developed his own tool of hanging curves that allowed him to very quickly design and see changes made to design be reflected on the building model. And actually the characteristics of these hanging curves are very similar, and the workflow that you use are very similar to the way architects use parametric design, because it allows them to make changes and see these changes reflected in the overall design. And I believe Gaudi took pictures of these designs and then compared different variations. And this is a very similar design process what we see in parametric design in architecture today, which help in these other examples that I show here very much in the generation of the form, but also in the production. The next example where tools are used in a generative way is in performative design, where certain parts of the building or building itself are optimized, maybe due to energetic performances, due to solar studies or acoustical simulations, which could, of course, be done manually as well, like simulated with physical models. However, whenever there's a large amount of data that needs to be processed or analyzed, digital tools are very handy. course, many other design methods that require or almost require digital tools, and perhaps some of them even became popular or originated from techniques that were introduced in these tools, such as morphing or dynamic simulation. Now, next I would like to talk about the effects that the digital tools have on the design process itself. This may, of course, vary depending on the involvement of the technology in the design process, as well as the background of the architect and the project itself. However, I try to identify a few of these general ideas, and I will present them to them. Now, the first approach is to look at it from a resource allocation perspective. Now, on the left diagram, these are both out of the 70s and 80s, you see the typical project from starting until the ending in the different phases, and on the y-axis you see the effort, the man-hour that's needed for certain phases. Now, in a conventional design process, the peak is in the production, meaning that in the production of plans. And this diagram suggests that computer-aided design freed up architects from this tedious working on detailed drawings and so on, from this very time-consuming task, and that architects can now use much more of their time on the early design phases and thereby create better architecture. Now, a very similar idea is what the second diagram suggests, which even shows that the production documentation, the big rectangle there, is now shrunk to a very small part due to using building information modeling, computer-aided design. Now, I think that these diagrams very much show the hope of the 70s and 80s that technology could contribute to a better architecture. Now, I believe also that the building information modeling particularly helped a lot to reduce the time that architects have to spend on especially in the later design phase. It makes it more efficient. However, I doubt that this time that the architects are free now, that they use it in earlier design phases, particularly because of economic constraints. So I actually doubt that architects now spend more time on the outline of a design than they did 30 or 40 or years ago. Now, this is some kind of historic perspective. Now, the next point I would like to talk about is the scale. Now, scale is a very essential part in the development of a design and the architecture itself. And a physical plan is usually in a fixed scale. That means it's a static representation of a design. And a certain scale, maybe 1 to 100 or 1 to 200 or 1 to 10, defines basically what the architect thinks about and which relationships are important at a specific scale. However, when we design digitally, we actually design in an infinite space where the architect can zoom in and zoom out, depending on which part of the project and which level of detail the architect wants to see. So the static representation of a fixed scale is now replaced with a dynamic view. And I don't want to say that it is only positive or negative. I would suggest maybe that drawing on a fixed scale, a manual plan, maybe allows the architect to focus more on specific functional and formal elements at a specific scale. Whereas when we are able to change the scale, it allows to see changes made to a part of the design reflected in the overall design. Now, as a consequence, of course, and I would suggest that when we design digitally, this distinction between 2D representation of the design and the objects and the model itself has been diluted in such a way that particularly building information modeling creates a database that allows architect to see changes made, for example, in the 3D model reflected in the floor plan, and vice versa. So it basically connects all these different documents, or even maybe some listings about objects and costs, combines these elements. And what is, from a theoretical perspective, I think different is that in a manual design process, the plan actually is one representation of a design at a specific scale, and it actually generates the design plan. And in a 3D environment, the plan becomes just one representation of the design. Now, this also, I believe, has an interesting phenomenon, namely that there is a shift from making a form towards finding a form. And what I mean with that is that when we use, for example, parametric modeling, it becomes very easy to compare different variations of a design and choose the one that the architect likes best or that performs best and continue with that design. So it is more a comparison of different variations, which is inherent in parametric design because the parameters can be changed and the results are seen immediately, versus defining a specific case of a form and developing that idea. So the architect tends more to weigh certain alternatives than developing one specific design. Of course, the geometry, computer-aided design has increased the shape universe that the architects can explore, and the software has made it very easy for architects to create very beautifully looking design, and it's almost the same effort to create a straight line or a spline or a plane or a work surface. However, the geometrical principles behind these shapes are very different and need to be understood. And usually the problems occur when it comes to the construction of these elements. And then it requires a deeper understanding about, for example, curvature, subdivision, offsets, and what are developable surfaces in this specific case, for example. Now, I believe this has led to a kind of knowledge transfer from this research field of architectural geometry into architecture. Now, new parts of mathematics and geometry become important because it is relatively easy for architects to create these very spectacular forms. And this also has increased or actually made this field for geometry consulting that allows architects to realize their complex shapes if they do not have the know-how. But I believe on the long run there is this knowledge transfer coming from mathematics. Now, in this specific case, it is important, for example, it was important to realize the geometry or to optimize it, that the geometry only consists of developable surfaces. Now, this leads me to the next point, where I think that the production of architecture is now maybe considered at earlier design phases. Now, the standardization, especially industrial standardization, has created a certain economy of shape, of repeating parts, which were the ones that are the cheapest. Now, with computer-aided manufacturing, this standardization has to some parts been replaced by mass customization on all different levels of scale. Now, for example, there is a very prestigious project for BMW. We see a research project on the top right, where especially the production is an essential part of the design itself, because it was assembled with a robot out of ropes that were bent around a certain structure. And we also see this, for example, on a roof extension on the left top side, or some tourist tower on the right bottom side. Now, the implications on the design process, I believe, are that when architects go into these more complex shapes, it requires to consider the design, the construction process and the materials at a much earlier design phase compared to when you just stay within the existing orthogonal shape of architecture. Now, of course, computer design is not only about making novel, beautiful forms. There are other ways of efficiently using computer design, but it's one aspect. And I believe it contributes to this fact that the architect is now maybe even more involved into the fabrication process. I would like to conclude by comparing the characteristics of a conventional design process with a computer-aided design process. Now on the left side you see the aspects of the properties of a conventional design process for manual tools such as the pencil or the paper are being used, whereas on a computer-aided design process, digital software and hardware is being used. When the architect designs with digital software, he designs in a dynamic scale, whereas on a physical plan in a fixed scale. Then there is this tendency or the shift from defining one specific form towards making a specific form towards finding a form out of various variations and weighing and choosing the best solution. This also has to do that when the architect draws on a plan, he basically draws a representation of an object, whereas with particular building information modeling, an object itself is defined with all its properties. This has the consequence that when using building information modeling or other CAD software, that the plan is derived from a model, whereas in a manual design process, the plan is actually the one that generates the design. And this has the implication that building information modeling operates with objects on a higher semantic level compared to, let's say, lines on a piece of paper. Now at the end, I would like to talk about some challenges or future trends in my work. I believe that the role of the architect has always been changing since the medieval master plan, or even before, where the architect took care of a lot of almost everything that was going on in the construction industry, towards the role of the architect today. And I believe that digital tools will play an essential factor in the outline of the profession of the architect itself. This of course has to do with that the tools that the architect uses have become much more powerful. However, this also raises the question whether the architect is actually still a designer or merely implementing objects that are given in the toolbar. For example, when you take a staircase, how likely is it that the architect is actually designing his own staircase rather than using the one from the object library and just choosing whether he wants to have the handrail in type A, B, or C and adjusting whether he wants a U-shaped stair or an L-shaped stair. I believe this holds true also for the other elements. And one way out of this is something that is called by Fussler, for example, design by tool design. What do I mean with that? It means that I think the more complex the design tools get, it is important that the design tool and the choice of which design tool is being used in the architect is a conscious choice. And we see this now happening with, for example, Grasshopper, where architects, at least within a certain framework, create their own small tools to do something that they actually want to do. And I believe the architect is at risk of using these very capable tools without actually understanding what these tools actually do. So this design by tool design, I think, is very important, and it should not be just reflected as some kind of computer science approach, but I believe it should be understood as an essential part of the creative design process itself, creating your own tools. And I think that leads to the last point that I would like to mention, which is that the design process will get much more interactive using these digital tools. This is, on the one side, the interaction between the human and the computer, but also what is happening within the software itself. It will become much more interactive. Okay, thank you very much.
Thank you for the presentation. On to questions next.
Okay. Now, I think the first question now, as I see this slogan, this design by a tool design would be directing you personally, actually. So if you would now, you're a finished architect, become a tool designer, in what direction would you start designing tools? So what would be an interesting goal in this very large, complex workflow from beginning of ideas or even before to the production phase?
So I think that the CAD software has helped a lot of parts and helped architects to deal with geometry itself, but it hasn't helped architects to deal with the function of a design. So I would actually start with doing that. It has happened, of course, to some extent, but I would go into and try to look if software can help architects to actually solve functional problems. And this has been done, of course, in research projects, but it hasn't been really implemented in commercial CAD software, as far as I know. And I would try to find a way of integrating and supporting the architects in solving organizational and functional problems, because that is something that is still, of course, up to the architect. However, I believe by delegating some of these procedures to the computer, we can actually, especially when we deal with larger buildings, with entities that the architect can maybe not overlook, help to create maybe new and better and novel solutions. So I think that this is an area where there hasn't been much done, and I would try to actually implement some of these in a way as easy as it is to use, let's say, more complex geometry in a standard CAD software.
When you're speaking of function, because function is also very abstract and general term, what functions would you address in particular?
For example, when we talk about the relationship between rooms, the connection of rooms, and the connection of a building with an outer space. So if we want to solve, for example, functional problems when we talk about an airport or a hospital, the functions are very complex, and the actions happening have all different stakeholders, and each of these people have to do their work, and I would try to analyze their behavior and see how what they do, for example, and try to optimize, let's say, the relationship between one room and another, which room should be connected, which shouldn't be connected. This has to do with the hierarchy of space and with the accessibility of a building.
And when you're thinking on these examples you mentioned, like hospitals or airports, I think it was the second example, how do we relate the functional complexity with this dynamic scale? What would be an idea to actually couple the things in dynamic scaling?
Well, of course, when we talk about implementing, let's say, functional optimization, the program needs to be able to change the geometry of a building and come up with geometrical solutions. And I believe that when we design, for example, hospitals, there are always designs that there are certain areas that are kind of grouped together, and they function as individual entities because they always used to function like this, and because it's very difficult to actually link something that's happening on a small scale and the processes to a larger scale. And by delegating it to computer scale, I think with functional constraints, I think it is possible to solve several levels of detail. as well as on a larger scale as well as on a smaller scale, which is probably not doable when the architect draws something by hand.
Well, I wanted to direct you probably in a little bit different direction, but actually, on your opinion, what is the problem with such a display like the screen shot of this grasshopper structure?
Well, it depends on, for an outside person, it's probably very difficult to understand. I mean, these tools are very complex on the one side, but also very usable on the other side. So I believe one problem of this is that it actually suggests that a certain design solution is an optimal solution. However, the parameters that the designer chooses to put into it is still very, very subjective, and they very much define the outcome of a design. So I think that these kind of approaches, they show a very rational approach and actually hide a lot of things that the designer still chooses to do.
Okay, now some other area. You mentioned the very early concept of the sketch pad. So this was already some idea in expressing graphical ideas, so to say. And besides the functional things, what could be the role of sketching in the digital domain?
Well, for example, here we said that technology actually helped them to realize his sketches in a way that the actual design of a building matches much more the design idea that he had with his sketches. Now, there are, of course, various ways of using sketching. I mean, we can use it in a very literal way, where you use actually a stylus and a pen and draw on the computer. Now, this is a very literal translation of using sketching on the computers. But I believe that when we talk about sketching, it is about expressing design ideas. And when we translate this to a digital world, it means that you have to, for example, think about a design idea could be expressed in an algorithm or in a functional relationship between objects or in an animation. And I think we have to extend this idea of physically sketching. However, of course, sketching also means that something that the architect does with his hands kind of creates a design. And this can be, for example, done when we look into all kind of different ways of input. For example, when the architect is able to draw with his hands something on a wall or somewhere and immediately translate these gestures into a design idea. Now, this is, of course, something that you might be familiar with in the game industry, where devices such as Kinect are become very, very affordable, and I believe that this type of technology is probably maybe also coming into architecture. So I think tracking the gestures or the behavior of the architect and translating it into a digital design could be one way of translating a sketch, so to speak, into the digital world.
Okay, one last question. Could you have some idea how to do sketching on the functional level? Now,
I think that when we look at functions in architecture, a sketch does not necessarily need to be in a scale, but it can actually already express the relationship of a design without defining its actual shape. Now, I think this is very similar when we look into parametric design, for example. It allows to define the relationships of elements without defining their actual shape.
Okay. so far.
You stated that computer-aided design has an impact on the whole architectural profession, and that it has produced some changes. And would you say these changes are rather, let's say, visible changes? For instance, that we are facing now new architectural styles, block architecture, parametric design, and the like. Or do you think the most important changes have produced rather invisible effects? Let's say the production process of developing a design within the architectural office, so that it's not so much visible for the customer itself, but for the insiders of the profession. And why would you take this position? I mean, what do you think are the most important changes that computer-aided design has produced for the profession?
I think it has opened up the profession a little bit. It has now allowed the know-how transfer, if you look, for example, from computer science, from material science, from other disciplines coming into architecture. Now, Gary said that when they started using CATIA, we also brought engineers from the aerospace industry into the office, and that completely changed the way the design process goes. And when we look at Foster and Partner, for example, they have their own research groups, special modeling groups that kind of assist architects in the design process and support them with tools that they specifically need. So I think it has, on larger scale offices, it has probably the effect that they now bring these people into the office. However, it has also created this architecture consultants, for example, as we see on a large scale with design to production, for example, that realize all these very, very prestigious buildings, or on a small scale, what, for example, Feasible is doing here at the Institute, where actually this idea of creating complex shapes is also given to architects on a smaller scale. So I think that we also have to distinguish between whether we use it as an imitation tool, which I believe most of the architecture offices do, because I think 50% use AutoCAD, a lot of them use building information modeling, and the way someone designs is very inherent to the person, and the person developed, and the architect probably developed the way he designs from his education to his profession, and he's probably not going to immediately change it because there is some technology available. So I think that the way this technology is used, it is very different in each architecture office. I spoke to one architect in San Francisco saying that he uses, for example, Form Z just as a sketching tool. He designs something, some forms, and another architect in his office is then putting it into Revit and makes it buildable. Now, he, for example, uses it just as a 3D modeling tool or a 3D sketching tool, as he would do with maybe sketching or developing physical models. And that's the workflow that this architect, for example, established. So I think it depends very much on which office you're looking at and at which scale of the project.
Now you have quite often mentioned Gary and his approach to architecture by, let's say, referring to special terms from aircraft design, for instance. And now I find this particularly interesting because if you take a look at the, let's say, the development of car design, if you think of the late 19th century when we did not have the automobile yet, and there was this transformation process from horse carriages or horse wagons into car design, it took like 30 years, and in the 1930s already we have a car design that's very close to what we have nowadays. And of course the first stage is very strong reference to horse wagons and the like, but then we ended up with streamlined design, and by the 1930s we had already two kinds of cars: race cars with streamlined design and family cars. Now, it's surprising that it would take the architects 70 more years to refer to car design to implement that into architecture. Now, what do you think is the reason? Could you argue why it took architects so long and why this development was so quick in car design? 30 years to come up with a perfect design, and then 70 more years for architects to make use of these technologies. Now, what do you think is behind that?
Well, I believe if you ask a car manufacturer, he will probably say that there are a lot of differences between the way cars looked in the 30s and that they look today. So these changes might be for us as an outsiders not as visible as No, but generally, I agree. And I think that in the late 60s, it was in the automobile industry, it was Bissier and Castillo who developed a mathematical way of representing the curves that they already had before, but representing them on a computer. And that allowed them to probably go faster from the design to the actual product itself. So I think it is, of course, the reason why the cars look very, very similar is because there's a very, very functional approach on the one side, of course, an aerodynamic approach to cars that we do not necessarily have in architecture. Of course, we can make buildings be aerodynamically optimal, but it is not the only parameter in architecture. So I think because car industry is also is of course very different to architecture because it's a serial production, whereas usually architecture is one of a kind of a design.
But you're absolutely right. Car production have very precise tasks. The car has to be fast, and aerodynamics makes a lot of sense. For houses, the function problem is much more complex, and hence cars have also needs. We are running out of time, so we have.
Okay, thank you.
I would
just
have more questions, but,
two quick questions. What is a datascape?
Sorry?
What is a datascape? I'm looking at this
datascape
figure
is something that I found in the literature, I believe. And it basically means, or it is described, for example, that you take certain constraints literally and translate them into an architecture. Now, I think this is something that was done by, for example, Willy Maas, I believe, with the case of the Monument Act, that he basically took the zoning laws literally and translated it into a building block and saw which of these, of what was possible to build. So it is a transformation of let's say, data or constraints directly into a form. Now this can be, of course, an ironic approach, this can have a functional approach, this can have an arbitrary connection, like analyzing sound data and translating it into a design. So directly translating data and into a geometrical shape and a design.
Okay. I think it's a good example of how IT terms are adopted by architects and turned into something completely subjective and difficult to understand by others, right?
I also think that, for example...
if I look at this graph, I understand scaling, morphing, folding. I understand reverse engineering. I understand parametric design. And then starting from the 90s, it becomes datascape, dynamic motion, animate form. Okay, performative design is another, that sort of one can relate to, but perhaps parametricism is another term which tends to be completely subjective and sort of influenced by these technologies, but sort of adopted very individually by these architects.
Mm-hmm. I also think that something that Peter directed me to is that the term reverse engineering, as it is understood in architecture, is not completely the same as it is understood, for example, in computer science or engineering, because it basically means of rethinking how an object has been constructed, whereas in Gary's case, he just digitized something and developed this. So it's also, that's why I put it under quotation marks, because a lot of these terms are used in architecture and architectural theory and do not necessarily match the original idea.
Exactly, but it gives an idea of how people think or how they actually adopt these sort of generic technologies. Second question actually relates to this parametricism reference. I mean, you quote a lot of architects, but Schumacher has written a lot about this parametricism, even he held it as a style on its own. Now, what was the reason for you to exclude discussing his work or his influence? Was this a choice which you made on purpose, or?
I actually, the way I approach and the way I use the literature was somehow that I was starting to read something and then see on which other people these people are related to. And I somehow knew about it. I think I even heard one of his lectures in the Audiomax last year or so. But I think that the term parametric design is so big nowadays, and everybody does some kind of parametric design. So it's actually, we have to be more precise when we talk about performative design is also parametric design, for example, or shape grammars is also parametric design. So I did not really decide to not choose him because I didn't like the ideas. I'm probably also not too familiar with, but I just didn't run across references in the literature.
Okay. One last question. I can't refrain from that. Okay. It's a building science question. How will they actually go about finding out how architects' thinking is really influenced by those digital tools? I mean, what you have done is you did a lot of research on how the architects say they use them, but how would you actually, just some ideas of how you would go about finding out if what they say is actually true, and what happens in their brains, when they work with computers?
I mean, I believe I came across a paper where a researcher gave students, a group of students, design tasks, the same design tasks, and divided them into groups. One of them using manual ways of developing design, the other one purely digital, and then asked them at the end and compared them how they came to certain designs and how they reason design. So that would be, for example, one approach of thinking of doing qualitative research in that area. Yeah. And another approach would be, for example, to compare buildings. Now, I thought about doing comparing buildings that were done pre-digitally and that were done now. I thought about doing that actually at the beginning, but then I actually realized that I'm actually a little bit more interested in the design process itself. So I believe that even if two architects come up with the same result, the one using manual means and one digital means, the design process, that how they get to that result might not necessarily be the same.
Okay.